was y equals c, some constant, times e to the 3t plus 4/3. Okay, let's side by side use the shortcut. You're going to see that it is much faster, and so I would never expect you to do all of this lengthy work when you can use the shortcut. But remember, the shortcut only works for first order linear differential equations. So sometimes we will deal with things that are first order quadratic, and so we will have to use some other method, which is the method that I just showed. Alright, so the shortcut, and again this was given in the PowerPoint, but the shortcut is if I have a first order linear equation written in this form. Again, it's linear, we can tell based on the way that this is written, and then it's first order based on first derivative. Then your general solution is always going to be in the form y equals c times e to the kt power minus b over k, where b and k are specific values. And if we go back to our original equation, so you might want to go back and look to see, I'm going to have to do that here too. So this was our original differential equation that was given to us. First of all, c is just going to be a constant that will show up in our answer. K is going to be 3, and here b is going to be negative 4. So if I plug those values into my formula, I have c times e to the 3t power, if I plug 3 in for k, and then minus a negative 4 over 3, which becomes plus 4 over 3. And you can see that we get the same answer doing it the long way as we do using the shortcut formula. So I hate to keep repeating myself, but I would definitely use the shortcut formula, but it only works for first order linears. So you're going to have to remember that if it's not a first order linear, that the other process is the one that you have to use. So speaking of that, let's go ahead and do an example where we have something that's not a first order. Oh, I'm sorry. That's my fault. It's a first order, it's just not linear. So my example number 2 here is going to be dy over dx equals 3x squared over y. dy over dx means first derivative. That does make it first order, but the fact that I have a squared x term means that it's quadratic. So let's go through the process of solving separable linear equation, separable first order differential equations, not linear. But the first thing I need to do is get my variables all separated so that I have y's on one side and then I have x's on the other side. And that was pretty easy to do in this problem if I multiply the y over to this side and I multiply the dx over to this side. Once that happens, I should now integrate both sides. It's always a good idea too to check to make sure that your notation ended up in the proper place with respect to the integral that you're trying to take, and that's just fine. If we take the antiderivative of y, that's y squared over 2, and again plus c now or plus c later, either way. Take the antiderivative of 3x squared and we'll get x cubed. Remember, I need to write a plus c somewhere. Let's solve this for y. I'm going to multiply by 2 on both sides of the equation. I don't need to multiply c by 2 because it's just a constant. Finishing this off, since it's y squared, I need to undo that by square rooting both sides of the equation. And that's my solution. So that problem wasn't too bad. Let's do one final example where we are not just looking for the general solution, but we're given some initial condition, and we're using that initial condition to find the particular solution to the differential equation. So this is example number 3. And the differential equation that's given will be y prime of t equals e to the t over 2y. And you'll see that I'll also be given some information about an initial value or an initial condition. And this means that I should be solving for c in the end so that I don't give a general solution, but I'm giving a particular solution. First things first, I don't like the y prime notation. I'm going to go dy dt. Finish writing the rest of the problem. Think about what happens next. Separate the variables. So I'm going to multiply by 2y to get all the y's on one side, and I'm going to multiply by dt to get all the t's on one side. Perfectly aligns my dt and my dy in the right places, which means I can now integrate both sides of the equation. On the left side, I'm going to get y squared. On the right side, I'm going to get e to the t. Remember, I need a constant c. Just like in the last example, I'm going to square root both sides. This is my general solution. And I want my particular solution. So I need to solve for c, and I need to use this initial condition. Now, for some reason, I just find it easier to work with this y squared version of the equation when I'm solving for c. That's just a preference. But what I'm doing here is letting y equal 1 and letting x equal the natural log of 2. That's what this ordered pair says. I used x, I meant to use t. In this problem, we're dealing with t. So y of t equals 1. That means y is 1 and t is the natural log of 2. So let's plug those values in where appropriate, and let's isolate the constant c. 1 squared is 1. E to the natural log of 2 is 2. And if I subtract, I'm going to get c equals -1. All I need to do now is take that -1, plug it in for c in my general solution, and I have a particular solution. And that's it. So those are the big ideas for this section, this very last section before we get into our chapter test. Again, differential equations. So you might also want to consider the fact that differential equations might be an entire course that some of you will have to take in the future. And this course, Calc 2, is the prereq for that. So this section right here is what is supposed to prepare you for taking that differential equations course later on. So the idea of knowing your first order, knowing what a separable differential equation is, knowing how to separate it, and how to find a general and a particular solution using different integration techniques, that's really all you need to be prepared to take the entire course.